All right, hi guys. It's 10 o'clock and the time for the webinar about taking your workflow to the next level using the Fem-Design API. My name is Johanna Riad and I'm based in the Gothenburg office of StruSoft, and I'm going to take you through this webinar. So welcome. If you have any questions or any comments or problems with the audio or video quality during the webinar, please write in the questions or chat section of GoToWebinar, and we will try to help you out as best we can. This meeting or this presentation will be recorded, so you can watch it afterwards as well. It's good to know. All right, so let's get started. So before we get into the presentation, I would like to introduce myself a little bit more. As I said, my name is Johanna, and my background is in structural engineering. I have a master's degree in architecture and engineering from Chalmers University of Technology, and I've also worked as a structural engineer for several years. And in my projects, or the projects that I've participated in, I've used programming quite a lot, and especially in large projects where there have been large amounts of data that we need to handle, it's been really essential. But also in smaller projects, it's been quite useful to make the workflow more efficient. So I hope to be able to show you a few examples on how you can utilize this type of workflow as well. Today, I will first go through the Fem Design API, just give you a short explanation of what it is and what it can do. And then I chose to show you 3 different examples on how you can utilize it. And I think the thing with the API work is that you can do kind of whatever you want. But by showing you a few different examples, I hope to kind of get your imagination started on what you would like to use it for. I see now that someone has a problem with the sound. Is there anyone else who has a problem, or is it everyone? Let's see.
I have sound now, if you can hear me.
Okay, yeah, good, yeah. Okay, most of the people hear me, so I hope it's worked out for you as well, Henrik. Okay, so let's get into the explanation of the API. And an API is an application programming interface, and I usually illustrate this by the picture here. And I think it's quite good to show you kind of the basic idea of an API. So it's a way of the user communicating with an application through another way than the normal user interface. And this is illustrated by the user, in this case, sending a request to the restaurant kitchen through the waiter, and the waiter bringing the food back. So the user in this case would be you, and the application is Fem Design. And I think this will become more clear when I show you the examples, exactly how it works. The Fem Design API can be used with Grasshopper, Dynamo, which are visual programming languages, and it can also be used with C# and Python that are more like traditional programming languages. But you can also use it in other environments if you want to. That would just require a little bit more setup from you. If you haven't used it before, I would recommend using either Grasshopper, which is quite easy for beginners to get started with, or C#, which is the main program or the main language of the API. That's where new features will be implemented the very first, even if we do try to keep up with all the other languages as well. And the examples that I'll show you today are in Grasshopper. Okay, so let's get back to the first example. And what I'd like to show you here is a connection between Fem Design and Tecla. And Tecla, as you may know, is a BIM program. and it's quite commonly used in certain type of buildings. But the same kind of connection that I show you to Tecla could also be done to, for example, Revit, if that's your program of choice. So let's see. So I already had my Tecla started, and I will just start up Rhino for you here. So Rhino is a 3D CAD program by McNeil, and the plugin Grasshopper comes with the program. So if you buy a Rhino license, you get Grasshopper as well. And I thought just as a start, I would just show you the basic concept of Rhino and Grasshopper and how they work together. I'm sure many of you already know, but I thought it might be nice if there's someone who hasn't seen it before. So let's look at it this way. So in Rhino, you can draw your geometry in different ways, just like in any other CAD software. You can draw 2D geometry like a curve, or you can do a 3D geometry like a box. And yeah, it's quite self-explanatory. You just kind of model the geometry you want. But the special thing is that you can also create this geometry by using Grasshopper. So I thought I would just show you with the very simplest component, which I think is a point. So here we have a component that symbolizes a point object. And you saw that when I created this little point here popped up. The Grasshopper components, they have their inputs on the left-hand side and the outputs on the right-hand side. And for this point, the default value was 0, 0, and 0. So that's why the point was created in the origin. But if we would like, we could change this so that the point is created in 0, 5, 0, for example. And you can kind of move it around. You could also have another point. Let's just do maybe this. And then we could create a line object between them. And if we change these, you see that the line also like follows along. So that's kind of the basic concept of parametric modeling, which you can do in Grasshopper through Rhino. And you saw that to find these components, I just double-clicked the canvas and I wrote the name of them. And I think that's a nice way, but you can also look through these different tabs and find the different components that are built in. And in our case, we're going to be utilizing the Fem Design tab as well and the Tecla tab. And these do not come with Grasshopper, so you have to install them separately. But it's easy to do. I'll just show you how to get the Fem Design one. So I've Googled this many times before. So you just go to Food for Rhino, which has a lot of different plugins for Rhino and Grasshopper, and you search for Fem Design. And here is the Fem Design API Toolbox. So you just download it, and when you've downloaded it, you need to right-click the file and press Properties, and then unblock. So just to show you, if we press a right-click on a file and go to Properties, if you download something, sometimes in the bottom here, it will say it's blocked, so you need to press unblock. And then you just drag the components into the Grasshopper canvas, and that installs them. So it's quite easy, but if you have any problems, you can just Google it and there will be plenty of explanations. So I've done that. I've downloaded the Fem Design library, which is here. And I've also downloaded the Tecla library, which is here. And this is what Trimble have created for Tecla, in the same way that we at StruSoft have created this for Fem Design. All right, so let's get into the example. Let's see. So I thought for this webinar, I've prepared some scripts because it takes a little too long to build them from the beginning, but I will go through them step by step so that you understand what's going on. Let's actually look at the model that I use first. So I've chosen a really simple example for this. It's just, this is a small balcony. It's a concrete plate of, I think, 2 by 4 meters or something like that. And it's got a fixed support along one edge. And what I've done is I've added some loads and I've calculated the required reinforcement for the slab. And what I want to do in the example is import the whole slab and the reinforcement into Tecla. So let's see. Let's actually do this first. So the first thing that I need to do is I need to find my and then I use the read through XML component from Fem Design that you can find here. Model reads through XML. And what that does is it opens the file and imports the Fem Design model into the Grasshopper environment. The next step is deconstructing the Fem Design model. And for doing that, I use the Deconstruct Model component, so model deconstruct. And what it does is it takes the Fem Design model and it gives you the major parts of it. So you get, for example, the country code, you get the bars, you get the shells, supports, and so on. What you can do is use this panel object to take a look at the different outputs instead of just hovering over the name. So here we can see that the country code in this model was S for Sweden, and we can see that we have a shell, just one, and we can also see that we have a support, just one. So in a bigger model, you would of course see a long list of these different things. So that's deconstructing the model, but we need to take it one step further and actually deconstruct the slab. We have all of the deconstruct components in this tab. And the way it works is that you usually have to do it in several steps, because if we did it as one component, then there would be way too many outputs. So we first deconstruct the model, and then we deconstruct the slab, and then, for example, if you want to look at the material, you would have to deconstruct the material. So it kind of gives you like a tree on how to go through the model. So in this case, it's the slabs that we're interested in. We're actually not interested in the support, so I'll just delete that. And we get the surface that we need. And we also get the surface reinforcement. And we have 4 surface reinforcement items because we have top and bottom reinforcement in the X and Y direction. So that's why it's 4. The next thing that I need to do is I need to change the scale of my model from meters to millimeters, because my Fem Design model is in meters and my Tecla model is in millimeters. And of course, if I had models in the same scale, I wouldn't need to do this, but it's quite easy to just multiply everything by 1,000 to get it to millimeters. So that's why, as you can see, I had the small slab here, and then I have the bigger one here. And I think it's time to actually create the slab in Tecla. So let's see if I can show you that. I just pull, actually I need to minimize Rhino. I'm sorry, it's when you work with Grasshopper and Rhino, you usually have 2 screens, but for the webinar, I only have 1. So that's why it's going to be a little bit moving around of different things. But so I pull the slab geometry into the Tecla component. And as you can see, the slab was created. And this is now a normal Tecla object that you could go on and modify in Tecla if you wanted. But we have one more thing that we need to do, and that's create the reinforcement. And what I've done here, I'm not going to go through these components exactly what happens because it will take too much time. But basically what I do is just change the format on how the reinforcement is output from Femdesign to the way that Tecla requires it to be input. So it's a little bit different. But you only have to kind of figure this out once, and then once you know it, you have the mapping between the Femdesign reinforcement and the Tecla reinforcement, and you can just use it again and again. But so this bar group, it requires one more input, and that is the slab. And I just pull that in there, and you can see that my reinforcement was created. Okay, any questions on that? That was my first example. Okay, someone asked if the Femdesign Grasshopper plugin is available in Rhino 7. We were actually working with Rhino 6 because that's where we started, but I think you should be able to install it into Rhino 7 as well without any problems. We need to acquire a Rhino 7 license and test it. We haven't done that yet, but please try, and I think it should work fine. All right. So of course, in this example, it's a very simple model, and it's not too complex to model manually. But I'm sure you can understand that in a bigger model, this would be quite a nice workflow that you can calculate the reinforcement in Femdesign and you can import it into Tecla. And it could also be the other way around. Maybe you have a model with reinforcement that you would like to import to Femdesign to check it, and you could just kind of reverse this workflow and do that as well. Okay, so I have a couple more questions that I might as well answer straight away if I can. The Dynamo package for Femdesign works in the same way in Revit. Yes, it does. If we have time at the end, I could just show you quickly what it looks like in Dynamo. But basically, Dynamo is built up in the exact same way. We have the exact same components. They just kind of look a little bit different because of the graphics. But it works in the exact same way. And then let's see, there's one more, I think. Someone asked if we're going to make any more examples of this done in Python, not in this webinar. Yes, we are. We're actually working on updating our examples in all of the different languages. Because there's been a lot of progress in the API recently, the examples that we have on the website are not all up to date. And we're working on getting examples in both C#, Python, Dynamo, and Grasshopper that you should be able to use as a starting point when you start using this. So there will be. You should just look out for it in the future. And someone is asking about updating reinforcements. And yes, sure, that could be done as well. It would require a different script because you would have to have some kind of mapping between the Femdesign reinforcement and the Tecla reinforcement so that you know which bars are which, so to speak. But that could absolutely be done. Not something that I'm prepared to show though. Okay, I think I will need to move on, and we can get back to some more questions a bit later. So let's see. So the next example is going to be deconstructing a Femdesign model into smaller local models. Let me just close down Tecla that we don't need anymore, and also close down this script. So the reason you might want to deconstruct a Femdesign model into smaller local models, that's something that I've actually done quite a lot when I was working as a structural engineer. And for me, it was because I had one large global model of the building, which I wanted to keep as simple as possible in order to easily understand the effects of what was going on, and also to keep the computation time light. And what I would do is I would look at that, and then I would export certain elements of the building into a local model in order to do the actual design of, for example, beams or columns. And I thought I would just show you a simple example on how you can do that. So let's go to Femdesign again. File, open, and that one is, I think, here. So this is the model that we're going to use. And it's, again, just a very simple model that I created as an example. Just wanted to show you one thing about it that's a little bit special, and it's that I've named the columns and beams in a certain way. Yeah, there we go. What I've done through another script is that I've named the columns according to the grid lines, the structural grid, and also the story that they're at. And I've done the same thing with the beams, just between two grid points, so A1 to A2 and level 4. And this I've done because I'm going to export the beams and the columns to smaller models or local models, and I want to keep track of which one is which, obviously. So yeah, but let's close that one down, and let's open the example in Grasshopper. So it's here. Okay. I just get some error messages because I'm messing around with different versions of the API. We're updating it internally in the company almost weekly, so that means I get these errors sometimes. But you won't get that if you just use the version that's on Food for Rhino. So I think it's fine. So in the same way as last time, I thought we would go through the script, and I'll tell you what it does. So the first thing that I need to do, in the same way as the last example, is I set the file path of the model that I'm going to use. I read the StruXML file into an FD model, and I deconstruct the model. So this workflow starts in exactly the same way as the last example. But in this case, we're interested in the bars and not the shells. And you can see here, this is what it looks like when you have multiple objects. So you have a long list of bars. We have 112. Numbering starts with 0. And the first thing that I need to do is deconstruct the bar objects into the curves. Yeah, it's actually the curves that I need. Let me just do this. See where my Rhino window is gone. Let's do that. Oh, there it is, yeah. Okay, so I need to sort my my horizontal from my vertical objects, and that's to differentiate between the beams and the columns, which I want to create 2 different local files for. And the way I do that is just kind of look at the vector that's along the line of the bar, and I look at if the z component is equal to 0 or not, and then I dispatch it into 2 separate lists. So let's just do this. Let's do that. So we see here we've got the beams and we've got the columns. And then what I do is I move them and put them on a long line, just along the x-axis. And that's just like personal preference, that when I do my design of the bars and or the columns and beams, I like them to be laid out like this in a neat row, I think. So that's why I move them there. And next thing that that happens is that I modify the bars with I use the same bar objects that I had before, but I just use a new curve for them. So instead of having the curves that were in the original position from the building, they're now in this position. And then I create the new Fem Design model from that, and I save it by using the model save to a new StruXML file. All right, let's see if we have any questions about that so far. Let's see. Oh, there are actually quite a few questions. I think maybe what I'll do is just go through with the presentation, and then I'll try to answer the questions in the end, because I'm afraid I will lose lose track of what I'm doing if I jump too much between questions and presentation. So let's go ahead. I just thought I would show you what the files look like now. So I go to File, Open, choose StruXML, and it's this one that's going to be the columns. And now you can see they're here in a long row. What I want to do as a next step is that I want to add supports for the columns, and I also want to add a small extra load that in this case comes from like an unintended an unintended load on the side of the column, but it could be maybe from having columns in a garage that could be hit by cars, or sometimes you have risks of explosions, and then you would have horizontal loads on the columns as well. So that's going to be done in a separate script. And I'll just pull that in there. Oh, same thing with the error messages as last time. No need to worry about that. And let's go through this one quickly as well. I choose the file path that I just showed you. I read it and I deconstruct it. It's the bars that I'm interested in. And what I'm going to do is I'm going to define supports for them. We've got all of the different available supports over here, and you can also customize them with using these different releases. I think this, if you worked with Fem Design previously, I think this will be quite self-explanatory because it follows the same logic. You define the translational and the rotational stiffnesses of the supports, basically. And here I just add a load case, and I also add the point loads that I want. And I use the component add elements. So I add the, I have the same Fem Design model that I had previously with just all the bars, and I add the loads, the load cases, and the supports to it, and save it to a new StruXML file. And what that looks like is like this. So now we have the support conditions that I want when I design these columns, and I also have this extra load that I wanted for the design. What I haven't shown in this example, but that would normally be a part of the workflow, is that you would take the internal forces, or the internal forces of the bars from the global model, and you would import those as loads into this local model. It is a little bit more complicated to do, and the reason I didn't show it in this example is partly because of time, and partly because there are going to be some changes in how we handle load exports in the API to make it even easier for the user to do it, because as it is now, there are a few manual steps that I think you as users shouldn't have to go through. But yeah, that should be really a part of this this type of workflow. Okay, let's see. So the last example is going to be this this Ikea chair that I chose. And of course, Fem Design is meant for buildings and not for furniture, but I just wanted to show you this as an example on how you can work with the complex geometry in Fem Design through Grasshopper and Rhino. So let's just close these down. And let's open the example. So this geometry I actually found online, but in your case, you would probably kind of get a geometry from the architect maybe, or you would be working with creating geometry yourself. And I think what I want to do is just show you like how you can work with creating geometry in Rhino really quickly, just to show you that it's easier than to try to do it in Fem Design straight away. So if we, for example, have a surface here, let's see, just going to rebuild it and show the control points. You can kind of just like pull the different control points in different directions to get the surface to look like you want it. And when you have a shape that you like, I don't know, maybe this is some kind of roof structure or something, then you can use the, oh, sorry. Then you can use the mesh surface, let's see, command, and you can get a mesh that's a kind of panelization of this freeform surface. And if you triangulate this mesh, then you're sure that the different panels of the structure are all flat, because if you have a quad, it could be out of plane, right? But I'm not going to get into too much detail on how you can work with different meshes. But there's again plenty of material available online if you want to try this out for yourself. Okay, so let's go back here again. And I want to show you how to get this geometry into Fem Design. So this workflow is in the other direction compared to the previous examples. In those, we already had a Fem Design model that we wanted to deconstruct. But in this case, we have Rhino geometry that we want to use to create a Fem Design model. So it's a little bit reversed. But first, what I need to do is that I need to select all of these surfaces that we already have, and I load them into my Grasshopper script. Let's see, internet connection is not completely as it should be, but I hope it's okay for you. So the first thing is creating the surfaces, and I import the Rhino surfaces, and I use the create slab components from the Fem Design API to create slabs from all of these different surfaces. And what I will have to tell you is that when I try to do this for the chair in its proper size, Fem Design gave me a lot of errors because I think the panels were too small. It's not, again, made for furniture, it's made for larger scale structures. So I had to scale up the entire chair to be like 60 meters wide or something. So that's why the dimensions of all of these things, they're not realistic at all. So just, yeah, if you see something that looks strange, that's why. But so I create the slab from the surfaces, a thickness that I set and also a material. And I do use the Femdesign material database, and I pick the material concrete with strength 30 because there wasn't any plastic material available. And I also set the average element size for the Fem mesh that I want to use. The next thing is creating the supports. And to do that, I look for all of the edge points of the surfaces which have a Z component of 0, because I know those will be on the ground. Finding them through a few built-in Grasshopper components. And then I create point supports. And the point supports, I've chosen to only define stiffness in the Z direction, because I want the chair to kind of be able to slide on the floor if there's a slippery terrace or something it's placed on. And the last thing that I do is I add the load. And what I did there is I want to have the load that would be the equal to a person sitting on the chair. So I find the midpoint here, and then I just choose all of the surfaces which are within a certain distance of this point to add the loads to. And I take the weight of the person, which in this case would be 80 kilos, and I make some calculations to find out what that surface load would be if it was evenly distributed on this area. Then I will create my Fem Design model from the shells, the loads, the load cases, and the supports. And I save it to a new StruXML file. Let's see. Okay. And there we can see it. It's created now, 1037, so it's our new one. And I'm going to open it in Fem Design and hope that it works. See, it's actually here. So here we go. Here it is. And as you can see, we've got the point supports, we got the shells, and we've also got the loads. As you can also see, the scale is really off. So that's why the point supports look so small. But we can try to run the analysis for this just for fun. And I think it might take a little while because we have a lot of panels that it needs to mesh and make sure everything is okay for. So I think it will take maybe a minute or so. When you're working with this type of geometry, you have to be mindful of the way that you create the panels. Femdesign will not really be able to mesh it if you have panels which have really pointy angles, or if you have panels that are maybe square but they would be out of plane. So you have to, well, it's a bit of a trial and error process, I think, but you have to really think about the meshing when you work with this type of structure. You also, of course, have to think about in shell structures like this, you have to think about instabilities. So it would be, I would recommend running a stability analysis on this to look for buckling phenomena. But let's just take a look. Okay, so yeah, you can see that the chair kind of behaves as, I don't know, I thought it would behave kind of like this. And if we take a look at the shell internal forces in the principal directions, you can see that we have lots of pressure here, and we also have the tension along these these arches. Of course, I think these really sharp angles of the panels cause some local effects here that you would need to really investigate to see if it's okay. But yeah, it's just an example for fun, this chair, of course. All right, so I think that's what I wanted to show you. I will take a look and see what questions we have and if there are any of them that I can answer. Let's see. Somebody asked which is better for new learners, Dynamo or Grasshopper? And for me, I started with Grasshopper, and that's what I would prefer. So I would recommend using that if there are no other factors that you need to consider. Grasshopper is slightly less complicated because it doesn't work with BIM objects. It works with just CAD geometry like surfaces and lines instead of beam objects or wall objects and that kind of stuff. So Dynamo is a little bit more complicated. That said, if you want to connect what you're doing to Revit, then Dynamo is a really good way to go. So Grasshopper would be my first choice, but there could be other factors factoring in. Okay, I also had a question. When using Grasshopper, can you create an application with a user interface? Well, yes, you can. I haven't really worked with that a lot myself, but there's something called Grasshopper Player, I think, which is the same as Dynamo Player. And it's a way that you can create a Grasshopper script, but then perhaps the person who's going to use the script doesn't know a lot about Grasshopper and they don't want to see all of the different wires because they will get nervous. Then you can have like an interface which just takes a few of the different inputs and displays them to the user that they can set, and then they can run the script without having to see it. Yeah, I haven't, as I said, worked with it myself a lot, but I think you should probably be able to find information online on how to do that. And of course, that could be a really nice way to get more users getting use out of the scripts that you create, even if they don't know Grasshopper. Okay, it says, do I need to install Femdesign to access the API for C# development, or is it available in public? So I can show you how to find the Femdesign API for C#. It is completely open source, so you can basically just go in and see every single line of code that we've written, but you can find it here. So it's on github.com, and you just look for StruSoft and Femdesign API. And if you want to download the latest, you can do it over here at releases, and that will just give you the finished like DLL that you need to reference to your C# project. But you can also go here and download the entire code and yeah, really dig into to what we've been doing. So that's where you find it. Can the renaming of beams and columns be done automatically somehow? Yes, they can, and that's actually what I did, and I showed it in another webinar. You can access the names of the, let's see if I have them here. You can access the names of the different objects through the identifier input, which is here, and it's the same for the slabs and bars and so on. And you can input the name that you want for the different objects in here. So if, for example, all of these panels had different names, I could have input that as well. If I don't, Femdesign will just create like the automatical names for you. Can you name your construction in Grasshopper? So it's a similar question. And yes, you can. I mean, you could do it in all sorts of ways. Maybe you had some kind of system that you built up in Grasshopper, or maybe you just had a panel which you wrote the names. So maybe I wanted to name my first my first object for plate 1 and the second one for plate 2 and so on. And I could just get a list of different ones. So yeah, you can. A project created in C# will run as an application or plugin. I think maybe it's easiest if I try to do a webinar quite soon with a similar topic as today, but showing you how it works in C#, because you can actually do a lot of different things. But basically, what you do is you have a C# project that you use to like open Fem Design, generate geometry, send different commands to Fem Design on what it should do, export different results and so on. So you're running Fem Design through the C# application regularly, or that's what I have done. But you could set it up in different ways. Okay, someone's asked a question in Swedish here. Let's see if I can translate it. What does it look like for beams with forces that need rotational reinforcement when you design them in a smaller model? Okay, so I think I will answer this question in more general terms. What you need to think about when you do this thing that I did where I deconstructed a global model and created local models is that you as the structural engineer need to make sure that you actually get all of the effects that you need into the local model. And sometimes if you have a really complicated structure where a lot of different things kind of have a big effect on each other, then maybe it's not suitable to deconstruct it into local models. But you could, of course, import the different internal forces from the global model into the local model. It could be any type of forces really, but you have to kind of make a judgment of when it's suitable and when it's not. See. Does Fem support mesh model? If so, can we use Rhino Compute to create mesh in Fem? No, at the moment, we don't support the mesh model in the way that I think you mean, that you could just kind of import a finished FE mesh. I'm not quite sure I understand the question exactly. But if you like, you could email it to me a little bit more detailed maybe, and I can try to answer it afterwards. My email is johanna.riad@strusoft.com. And of course, that goes for all of you. If you have any questions that you don't want to ask here, or that I don't answer the way you like, please just email me and I'll try my best to answer them afterwards. Someone else asked, how would the workflow be in Python? And I think what I'll have to do is just kind of leave that question for a later webinar, because I think it would be really nice to show you guys who are interested in C# or Python, which are quite similar, on how it works. But it is completely different than, well, not completely different, but it's set up in a different way than Grasshopper and Dynamo. So I think it's a too big question to answer meaningfully right now. Someone is asking if it's possible to read results from a model using Grasshopper Fem Design script. Yes, you can. As I said, we are working on improving the way that that is done, but I can show you how it looks like right now. So let's see. So if you have a model that you want to run an analysis, you have the possibility to import a BSC path. And the Bsc file is the file that decides what results should be exported. And the easiest way to create a Bsc file is to go to your model and use the list tables. And you would perhaps want to, maybe you want all the nodal displacements. Let's see at the batch, and you want all of the point support group reactions, and you want, yeah, let's say it's just those that you want. You can choose whatever you like. And then you press Save Batch, and you save it as a Bsc file. And then what you would do is just in Grasshopper, you would just reference that Bsc file. So let's see where I put it on desktop. And you would pull that into the Bsc path. And that would give you, when you run the script, in the same folder as you have the Bsc file, I think, or if it is the model file, you will get CSV files with the results that you can use in any way you want. And you can, of course, if you create CSV files, which are comma separated value, like similar to Excel files, you can import those back into Grasshopper and manipulate them in the ways that you want or get the values that you want. But this is what we are working on making even easier so that you don't have to go through those extra steps. Where to start learning API from? And please recommend some resources to learn API. Good questions. And I think what you can do, and what I've recommended to my colleagues who are starting to learn the API, is to download the Fem Design API and install it to Grasshopper. And then what you would do is, if you have a model that you've already created and you save that as a StruXML file, and then you use these different deconstruct components, then you can kind of get an idea of how it's all built up and kind of learn by doing, sort of. But that being said, we are working, as I said, on creating better examples and some scripts that you can kind of start from on our website. But there are a few now, but there will definitely be more in a short time. Somebody asked if Dynamo and Grasshopper can be used as free of charge for Fem. And our Fem Design API is completely free and open source. But what you need in order to use Dynamo is you need an Autodesk Revit license. And for Grasshopper, you would need a Rhino license. And if you already have Autodesk products, then you can just kind of start using Dynamo. But if you don't have either, I think a Rhino license is not very expensive. You can look it up, and then you get the license to Grasshopper. It's included in the Rhino license. Somebody asked if previous webinars are still available to access, and I think they are. I think I will have to check with my colleagues and get back to you on that. I'm not sure how long they're saved for, but I thought definitely for this webinar, I will send out the link afterwards, and then you can like watch it. And if you want to try to follow along what I did or something like that, then you can play and pause and play and pause and get started in that way. Okay, so we're getting so many questions, which is really nice. I hope I have time to answer them all, but I think I will go on until 11. And if there are any questions after that, I will have to try to answer them by mail afterwards. Somebody asked, to what extent can you do an automated mesh sensitivity analysis by using Grasshopper and Fem Design? Yeah, good question. So we had this average element size, right? And that you can set for your model. And what you could do is that you could set up, if you perhaps wanted to start with a mesh that was an average element size of 1 meter, and then you could do 0.8 meters and then 0.6 or whatever. You could do that, and you could make sure that you save the results, or some, don't have to save all of the results, but some of the results that you want to use for your mesh consistency check. And you could save those to Excel files or to somewhere, I don't know where you want to put them. But then you could try all the different versions and have some kind of criteria when you think that the mesh size, well, the results converge. So that would be the okay mesh size. I'm sorry, that was a messy explanation, but yes, you could definitely work with it. And I can try to think about how I would set it up and perhaps answer you in more detail if you send me an email. Import and change geometry is the main purpose in API. What is the benefit working with APIs? Structure engineer becoming a developer. Smiley face, smiley face. Well, I think the idea behind the API is that you shouldn't have to be a programmer or developer to use it. It should be easy enough so that you, with like very basic programming language, can access the potential of working through an API. And I think if we go back to like the main ideas of an API, is that of course when you set up workflows, you can create much more efficient workflows if you have tasks that are repetitive. So if, for example, you're working with prefabricated concrete buildings, you a lot of the time you want the loads exported in the same way, and you want the same checks to be done for the connections or that kind of thing. You could just save yourself a lot of time by setting up a script once, and then you can just use it for all your projects. Another example on where I think it's really useful to use the API is when you're working with slightly more complex geometry, because if you wanted to create a grid shell structure like this and you want to draw it in Fem Design, it's going to take you a long long time. So I think that's one time where it's just almost necessary to work with the API. But I think there are a lot of different ways to use it, and I think that when you kind of get started, you find more ideas that you want to try it out for. And I think you can also look and find a lot of examples on how people use API online if you want to get more inspiration. Let's see, someone asked, maybe it was asked before, but can we create plugin add-in for Fem Design? So yes, you can. Yeah, definitely. I think that is something that we could talk about in a webinar where we focus on C# and Python. But you could, for example, create a Windows Forms application that accesses your Fem Design model, and you could have some different buttons that the user can press, and it will do different things in Fem Design. So definitely. And I think I'll do one last questions, and the remaining ones I'll try to answer per mail. So can you manage the edge connection in all directions in Grasshopper? Yes, you can. I haven't actually tried it out myself, but I know that you can. So there are different ways of managing the edge connections here, and I think you can also work with these releases. What I would do if you look at it, maybe you can just figure it out by yourself. But if you don't, then please send me an email or send it to the Fem Design support, and we can take a look at it for you and maybe send you an example on how you set it up. Okay, so I think that's it for today. I think it's been really, really nice showing you this, and I'm happy that there were so many questions because I think that shows that you're interested in this subject. If you have more questions in the future, please don't hesitate to contact me. You can also write directly to the Fem Design support if you are having any problems with the API or if you have any questions on it. So yeah, thank you very much. And I think we'll end there. Bye-bye.